all first PUC students and welcome to Deeksha Karnataka YouTube channel. Most of you watching our channel for the first time, so I request all of you, before continuing with this video, subscribe to our channel. The subscribe button is right there and click on the bell icon, and you can trust us that your entire first PUC and second PUC, including KSET, JEE, your entire journey will be safe with us. So better subscribe now before you lost our channel, right? And today I am going to discuss the most important questions from your first PUC first unit test chapters, right? So go nowhere, sit tight, and if you watch this video, I can guarantee that you will be very close to getting 35 out of 35 in your first unit test. That is the first big test after you came to your PUC journey, right? This is the first important test. You have some monthly test maybe before, but this is the first big test, and these marks will be recorded in your board's portal as well. So let's continue with this revision. So first of all, let us look into the chapters that we are going to discuss in today's lecture: units and measurement, motion in a straight line, motion in a plane, and laws of motion. If you have any other chapters in your first unit test, you can mention that in the comment below. I will try to compensate all the other chapters that is there in your first PUC syllabus later on in another supplementary video, but these are the major 4 chapters which is common for most of the students across Karnataka in your first unit test, right? So if you are someone who is struggling to understand what type of questions I might get from these chapters, what are all the different varieties of question I will get from this chapter, so everything will be covered in this lecture, right? We are already doing it. You might have seen the chemistry video and maths video. Now let's continue with physics. So first chapter that we are going to discuss is units and measurement chapter. So first, obviously, in your PUC journey, if you have seen any of the previous year papers, the first portion is MCQs, and most of the students basically suffer because of first of all, they don't understand the question maybe, or they do not read the MCQ questions, and they suffer a lot in the MCQ section. Okay, you can ask your seniors. You might think that MCQs are easy. Actually, it is not super easy, but it is not super difficult as well. So what is the crack code for MCQs? Read the question at least 2 times. That is the first point, first thing that you have to do in case of answering MCQs. They are easy to answer. In your unit test, there will be 7 or maybe 8 MCQs based on the paper. You can ask for paper blueprint from the teacher who is making the question paper. 7 is standard number of MCQs. Some teachers tend to give 8 MCQs as well. 7 MCQs and 3 fill in the blanks is what is the general composition of a paper, right? Now let's see the MCQs from the chapter units and measurement. First MCQ: which of the following statement is incorrect? So you have to be careful and answer properly. I have underlined that statement incorrect over here. That will not be given in your question paper. They will just mention simply incorrect. Okay, so you have to be careful that out of the 4 statements, 3 of them are correct, only 1 is incorrect. So you have to identify which one is incorrect. So you find first statement, you read the first statement and you find, okay, this is a correct statement, this must be the answer, you answer it. So before answering the question, read the question twice. That is my suggestion to you, and if it is incorrect or correct, underline that yourself so that you will be you have a clear mind that okay, they ask about incorrect statement. That means 3 are correct, 1 is only incorrect. All non-zero digits are significant. Yes, this is a correct statement. All non-zero digits 1, 2, 3, 4, 5, 6, they are all significant. So this is a correct statement. All the zeros between 2 non-zero digits are significant. Yes, for example, 2002, all zeros are significant. So this is also a correct statement. The trailing zeros in a number with the decimal point are significant. For example, 2000.00. So all the zeros are significant. Okay, if there is a decimal point involved, all the zeros are significant. So that means this is also a correct statement. the power of 10 is counted while counting the number of significant figures. This is incorrect statement. This statement is incorrect statement, and that is what we are trying to find. So this is an incorrect statement. Remember that if I write 2 into 10 to the power of 3, it has only one significant figure. This is not counted as significant figure. Okay, you have to remember that. This number is not counted as significant figure, only the number which is given as scientific form. This is called scientific form. So here only 2 is significant, not that power of 10. Now next question, which of the following physical quantity has same unit in CGS, FPS, MKS and SI system of unit? Okay, CGS means centimeter, gram and second, FPS means foot, pound, second, MKS means meter, kilogram, seconds, and SI system. So what is common between them? As you can see, SSS. So second has the same unit in all the system. And what is second? Second is basically the time. So time has the same unit in everything, and its SI unit or MKS, CGS, FPS, everywhere it is only one unit, one standard unit, that is seconds. Okay, not minutes, not hour, only seconds is the scientific unit. So for time, unit remains same no matter whatever unit system you are using. Next question, which of the following physical quantity is not a fundamental quantity? So there are 7 fundamental quantity, right? If you have seen my previous lectures in the channel, that is there in last year's video, I have discussed it. I am not going to discuss all the 7 fundamental quantities, but most 3 common fundamental quantities are mass, length and time. Apart from that, there are electric current, okay, there are temperature, we have luminosity, right, amount of matter in a substance. These are the main fundamental quantity. Now here energy is not a fundamental quantity. Okay, length, temperature, electric current, they are all fundamental quantity, but not energy. So energy is the correct answer for this question. So 3 of them are fundamental quantity, only 1 is not. So energy, work, etc., force, they are not fundamental quantity. Next, the SI unit of electric current is, the SI unit of electric current is ampere, right? Don't get confused, it is ampere, not watt, not joule, not volt, it's only ampere. Okay, so ampere is the with the A small, you have to be careful. Ampere unit with A small. If you write A capital, that is the name of a person, okay, and A small is the unit of current, and also its symbol is capital A. Even though its symbol is capital A, when write it in a complete word ampere, A should be small letter. Okay. Next question, the SI unit of solid angle. What is the SI unit of solid angle? SI unit of solid angle is steradian. You have to remember that, there is no other option. Steradian is the SI unit of solid angle. Unit of SI unit of normal angle is radian, not degree. Okay, it's radian, and SI unit of solid angle is steradian. Okay. Fill in the blanks. This is also some pain point for some of you. There will be less number of fill in the blanks in your unit test, but when you face 5 of them in a paper, sometimes it is very difficult to identify 1 or 2 of them. Okay, so there will be some closely matched fill in the blanks. So if you are careful, again, first thing when answering fill in the blanks, you have to see whether the option is making any sense or not. That is the first priority. Okay, if it does not make any sense, then obviously it is not the correct answer. If it makes sense, then you have to be careful whether it is a correct option or wrong option. Okay, there will be some cases. For example, let's see the first question. Dash is a basic physical quantity. So which of the following can be a basic physical quantity? Strain, plane angle, temperature, frequency, significant. Obviously significant is not fitting over here. Significant is not a quantity, so significant is a basic quantity, it does not make any sense. So definitely significant, you can rule it out. Only one physical quantity is basic among them, that is temperature. So temperature is the correct answer for the first question. And when you answer it, try to strike it off or mark it or underline it, so that you are sure that this one is used. And one beauty of that, one option is not used twice in a question. It is only used once. Once it is used, it is done, right? but they will give you one more extra option in the so 5 question means 6 options they will give. If there are 3 questions, they will give you 4 options. So one of them will be little bit difficult to answer. In a number, the zeros between two non-zero digits are. So in a number, the zeros between two non-zero digits are, obviously among all the options it is a significant, makes sense. Other things are not making any sense. Strain does not make any sense, plane angle does not make any sense, frequency also does not make any sense. So it will be significant. So here the answer will be significant. Significant is done, cross it. Dash is a supplementary quantity. So which of the following is a supplementary quantity? Supplementary quantity is strain. Okay, secondary unit, right? So it is a secondary unit. The physical quantity that has neither a unit nor a dimension is plane angle. Sorry, there is a mistake over here. There is a mistake over here. Okay. It will be strain, it will be plane angle, sorry for the mistake. So plane angle is a supplementary unit, okay, and strain does not have any units. Strain does not have any units. So be careful when answering such questions. So as you can see, the question, even though it looks very simple, but there are some chances that you make the mistake same as done over here. Okay, strain is a dimensionless and unitless quantity. Strain does not have any dimension. Plane angle is a dimensionless quantity, but it has a unit. Even though it is a dimensionless quantity, it has a unit which is degree, radian, steradian, but actually it is a dimensionless quantity, does not have any dimension of its own. Okay, so be careful about this kind of question. The physical quantity having the dimension m to the power 0, l to the power of 0. So both strain and plane angle are done. So cross them. So the physical quantity having the dimension m to the power 0, l to the power 0, t to the power minus 1 is frequency. Okay, frequency is the dimension same as m to the power of 0, l to the power of 0 and t to the power of minus 1. So frequency will be the last answer. Sorry for the overlapping. So frequency will be the last answer for this question. So everything is correctly answered. So you can answer all the questions correctly if you read the question and try to understand them properly. Okay, if you have any doubt, leave it. Try to answer them later on once your paper is over. Don't have any doubt. Okay, whenever you write, if you have any doubt, what happens? No, when you start writing the 2 marker, 3 marker questions, that keeps on going in back of your mind. Okay, that question maybe is incorrect. So leave it. Forget it later on once your all the answers are done, and then you can come back and answer the questions that you have left, right? And you will get plenty of time to answer those questions. Okay, time is not a problem. Only thing is some of it you have to memorize, some of it you have to understand, right? For example, let's see one understand level question. Give any 2 limitations of dimensional method. Okay, so dimensional method is not foolproof. Dimensional method means when we use the method of dimensions to determine the dimension of some unknown quantity. So what are the drawback? First, it cannot determine the values of numerical constant in equations. This is sufficient to write. I have just written one extra explanation for that. So if you are someone new who has not opened the book, who has not studied anything, they can still answer this question even without open the book as well. So it cannot determine the values of numerical dimensionless constants. For example, if I say area of a circle is area of a circle is pi r square. Okay, so it cannot, this pi cannot be determined using dimensional method. Okay, you can say okay, area is proportional to r square, that can be determined, but you cannot find this constant pi from this expression. Okay, for example, numbers such as half, pi or e that appear in many physical formulas cannot be found using dimensional analysis. Okay, it cannot be applied to formulas containing trigonometric, exponential or logarithmic functions. This method only works for equations that are algebraic and consists of products or ratios of powers of quantities with dimensions. Okay, it cannot be used for example, if I say A is equal to B sin theta, this kind of equations cannot be determined using dimensional method. Okay, or if I say that n equals to n naught e to the power of minus lambda t, so this cannot be determined using dimensional method. This kind of equations cannot be determined using dimensional method. Okay, clear? So anything contains sin theta, cos theta, or exponential terms or logarithmic terms, they cannot be determined using dimensional formula. Okay, also only algebraic equations with multiplications can be determined. Now state the principle of homogeneity of dimensions. So dimensions has to be homogeneous. What are the principle of homogeneity? The principle of homogeneity of dimensions states that all terms in a physical equation must have the same dimensions, that is, the dimensions on both sides of an equation, and in every term must be identical for the equation to be physically meaningful. So for example, if I say that A equals to B plus C, very simple equation, right? Very simple equation. What is the meaning of this homogeneity principle? It means that all the terms on the left hand side, whatever is the dimension, right hand side the dimension will be same, and because there is a addition, individually everything will have the same dimension. That means dimensions of A will be equals to dimensions of B will be equals to dimensions of C. Third bracket represents dimension, right? So individually all the terms will have the same dimension, then only you can add these two quantities. For example, you cannot add kilogram with second, 2 kilogram and 2 second. Can you add them? You cannot add. You can add kilogram with grams probably. Okay, because units may be different but dimensions are same, so you have to convert grams into kilograms or kilograms into grams, and you can then add them. So unit does not matter, dimension matters. Okay, so they all have to have the same dimension. You can add only quantities which have the same dimension, not the quantities which have different dimensions. Next question, write any two rules for writing significant figures. So there are a lot of rules for writing significant figures. They have asked you for any two rules. You can study one more extra rule if you want. All non-zero digits are significant. For example, the number 456, all three digits 456 are significant. Zeros between non-zero digits are significant. For example, in 4005, all digits 4, 2 zeros and 5 are significant. Okay, there may be one more point, the number with trailing zeros in a decimal number are significant. That also is a point. First MCQ, if you remember, that is also a point. You can remember that if in case they ask it as a 3-marker question. Okay, easy to remember. Now next, check the dimensional correctness of the equation x equals to v naught t plus half at square, or x equal to ut plus half at square, whatever form they might give. Basically this is the same equation, right? So first of all we have to check what is the dimension of x. X is displacement. So displacement means what? The displacement means, so first of all we will write LHS. Okay, LHS means whatever in the left hand side, right? Dimension of displacement. What is the dimension of displacement? It does not have any mass, so m to the power of 0. It has only one length, so L to the power of 1, and it does not have any time, so T to the power of 0. So this is the dimension of displacement. Okay, now let's check the dimension of the V naught T. Now we have to check the RHS. For RHS we have to check both quantities, this as well this. Okay, this half does not matter, it's a constant, so we do not need to worry about this half. Only thing you have to check the dimension of V naught T. Okay, so what is V naught T dimension? V naught T dimension means dimension of V naught and dimension of T. You have to multiply them. Okay, what is the dimension of V naught? V naught has a dimension of, obviously mass is not there, length t to the power of minus 1. So length 1, t to the power of minus 1. So in case you forget the dimension, try to remember its SI unit. Okay, that is very helpful. So V naught is a velocity. So what is the SI unit of velocity? Meter per second. So meter means length, per second means per time, that means t to the power of -1, right? So what is the dimension of time? Dimension of time obviously is time, so you have to multiply it. Okay, so now you add them, m to the power of 0, l to the power of 1, t to the power of -1 plus 1, right? So this is 1, right? So this -1 and this 1 will be added, same quantity, so you get this as m to the power of 0, l to the power of 1, t to the power of 0. So this is dimensionally consistent, right? Now third term also you have to check, that is at square. What is the dimension of acceleration? Again you have to write this as a into t square. Okay, what is the dimension of acceleration? Now if you forget, again remember the SI unit. SI unit of acceleration is meter per second square. Meter per second square, meter is L, so no mass involved, so m to the power of 0, l to the power of 1, t to the power of -2, and t square, again it's the dimension of t to the power of 2. Okay, so it will be m to the power of 0, l to the power of 1, t to the power of -2 plus 2, so it will be m to the power of 0, l to the power of 1, t to the power of 0. So very simple, nothing rocket science in that. Okay, so very simple proof. Okay, so that means the this equation is dimensionally consistent. They might give you some weird equation which is not dimensionally consistent. So in that case you have to find the dimension and show it to them that okay, this is not dimensionally consistent. Okay, so be careful, they might give you a question where they might ask you that check whether it is dimensionally consistent or not. So in that case it might be possible that one of the term is given such a way that it is not accurate. So so in that case the dimensions, for example here dimensions matches, right? Every three quantity they have the same dimension, but if they do not have the same dimension, then the equation is not dimensionally consistent. You have to write one concluding line saying that this is the equation is dimensionally consistent. The equation is dimensionally consistent. Now let's move on to the next question. Now this can come as a 3-marker question as well as 5-marker question, both type I have seen that. Derive the expression for period of a simple pendulum which depends on its length and acceleration due to gravity g using dimensional analysis. Now this is a 3-marker question. If the same question is asked using the fact that mass, length and g, okay, even though mass does not play any role over here, but if they ask you or add the mass, you have to show that the dimension of mass is 0. So that will be a 5-marker question. And in your unit test, even though this question is not super important for annual exam, but for your unit test I have seen teachers prefer to give this question as a 5-marker question. So be ready for that in case you are wondering what type of questions I might get from this chapter. This is a very common questions that you might get from this chapter. Now let's see. So time period, basically what they said, time period is proportional to length and time period is proportional to acceleration due to gravity. So both are proportional, so from there we can write time period is proportional to mass into gravity. Now how they are dependent on it, that we have to find out. Okay, so let's say it is proportional to a, l to the power of a and g to the power of b, that we do not know. So we have to find this a and b. Okay, now we have to write the equation. What equation we will write? T equals to some constant k, l to the power of a, g to the power of b. Here k is a dimensionless constant, right? So here k is a dimensionless constant. Now we have to put the dimensions individually and then compare it. So what is the dimension of t? Dimension of t is m to the power of 0, L to the power of 0, t to the power of 1. Time period, that is the time, that is second, meter, or a second or minute or hour, right? Mostly seconds, but it can be minute in some cases. So this is the time period, dimension of time period. So here what is the dimension? This is the dimensionless quantity. So what is the dimension of L? Dimension of L is m to the power of 0, L to the power of 1 and t to the power of 0, simple length. So it will be to the power a, right? Now g, what is g, by the way? G is gravitational acceleration. So what is the dimension of acceleration? We just did it in the last question, m to the power of 0, L to the power of 1 and t to the power of minus 2 to the power of b. Okay, let me write it little smaller so that you can see that it is overlapping. Okay, so be careful while writing the dimensional equation. Okay, so it will be m to the power of 0, and try to mention everything in detail so that you don't make any miss, and m to the power of 0, L to the power of 1, t to the power of minus 2 to the power of b. Now as you can see, mass is 0 in all the cases. So in case they ask you what is the dimension of mass, there will be one more term with m to the power of 1, but that quantity will be coming out to be 0. For example, if you add mass to the power of c, then first you can see that everyone has mass 0. So this c must be also 0. So it is independent of mass. Okay, in case they add the mass term, don't get afraid, you have to put the mass over here and you have to show that c equals to 0. So because everything else is 0, that means you can write that c directly will be equals to 0. Okay, so first c equals to 0, and it will only come in a 5 marker question. 2 marker 3 marker question, they do not add mass. Okay, 5 marker question, just to confuse you, they will add mass. Now what else? We have to compare the what is the total dimension of length. So on left hand side, total dimension of length is 0, right? But in right hand side, the length dimension is not 0. So what is the dimension of length? 1 into a, that is a, plus 1 into b, that is b. So a plus b equals to 0. So a must be equals to minus b. So this is the relationship between a and b. We will use that later on. Now let's compare the dimension of time. So this is the dimension of length. This is dimension of mass. Okay, this is dimension of length. Now dimension of time. So basically we are comparing dimension of time from both sides. So here what is the dimension of time? Power. Power is basically 1. Okay, what is the power on the right hand side? Power on the right hand side, 0 into a is 0, minus 2 into b is minus 2b. Okay, so from here we can calculate the dimension of b. So b is basically minus half. So b is minus half. So what is the value of a now? So we know that a is minus b. So a equals to minus of minus half, that is plus half. Okay, so b is minus half, a is plus half. So how does the equation looks like now? So t equals to some constant k, L to the power half, g to the power of minus half, or you can write this as k L by g to the power of half. Okay, minus half means division, or you can write this as k square root of L by g. So this is the relation of time period. Okay, the constant k is not required to write. If you want to write, you can write 2 pi, otherwise 2 pi is not necessary. You just keep it as k, because from dimension analysis the constant cannot be calculated. So this is a perfect answer for this question. Okay, clear? Now Next, and also if you want to download the PDF of this lecture, you have to join our WhatsApp channel. The link of the WhatsApp channel is given in the description, right? So there you will get the note for this lecture as well. Let's move on to the next question, next chapter, motion in a straight line. So these are the 15 questions that we have done from the previous chapter, are very, very important. So if you have any doubts in units and measurement chapter, you can check the previous questions once more in a 2x speed perhaps, or you can download the PDF lecture and you can check it yourself. And I recommend you to solve the questions again once more on your own without looking into the solution. Now first question, a body cannot have, so again cannot have, that means 3 of them it is possible, 1 is not possible. Constant speed and varying velocity, very interesting. Can it have constant speed and varying velocity? Yes, very much possible if it is moving in a circle. If it is moving in a circle, it can move with a constant speed. Speed does not require any direction, but at each and every point its direction will change. So direction changes means even if the speed is constant, the velocity will be changing because direction is changing. Okay, uniform circular motion. Uniform circular motion is an example where velocity is changing but speed is constant. An acceleration and a constant speed. Again, uniform circular motion, because the velocity is changing, it has a centripetal acceleration, but the speed is constant. This is also possible in the circular motion, uniform circular motion. Uniform velocity and varying speed. So this is very, very interesting. Uniform velocity and varying speed. So what is speed, by the way? Speed is the magnitude of velocity. Speed is the magnitude of velocity. If velocity is uniform, that means it is moving in a straight line, in a straight direction without changing the direction, and its magnitude must be same. That is, if you delete the direction, the magnitude will also constant. Uniform velocity means magnitude constant, direction is also constant, and the magnitude of the velocity is basically speed. So if velocity is uniform, speed cannot vary, speed has to be same. So its opposite is possible, but this is not possible. So this is not, a body cannot have uniform velocity and varying speed. So this is incorrect, this is not possible. So this is the answer that we have to find. Last option, you can just check it, non-zero speed and zero acceleration. Non-zero speed, zero acceleration, straight line motion. If it is moving with a constant speed in a straight line, acceleration is 0, okay, but speed is obviously not 0 if it is moving in a particular straight line without changing its direction. Okay, that means velocity is constant, speed is constant, but it is not 0, so acceleration is 0. Okay, so this is also possible. Now next question, the slope of the tangent drawn to a position time graph at any instant gives. So slope of the tangent drawn to the position time graph. Suppose it is a position time graph, and if you draw a tangent and the slope, so what is position, by the way? Position is x and this axis is time. So slope means, what is the meaning of slope? Slope is basically the angle it makes, okay, tan of that angle. So this angle, tan of that angle. And how do we make it, measure it? Suppose this is delta x, suppose this is delta t, that is the change in position. Delta x represents change in position, delta t represents change in time. In the same time, in the delta t time, whatever is the change in position gives us the delta x, right? So what is the slope of this graph? Slope of this graph is given by, slope is represented by m. You will learn that in mathematics if you have not yet so, okay, delta x by delta t. Okay, delta y by delta x is basically in a graph, you will learn that delta y by delta x is the slope. In this case, delta y is basically x, because we are representing displacement along the y direction, so that's why this is delta x, so don't get confused. Okay, so this by this is the slope always. So delta x by delta t is change in position divided by change in time. So position by time is what? Position by time is its velocity, but it is instantaneous velocity. It is instantaneous velocity. At this particular instant, whatever is the velocity, okay, that is called instantaneous velocity. Okay, to calculate average velocity, the method is different. So this gives the instantaneous velocity. This gives the instantaneous velocity. Okay. Now, next question, the distance time graph for a particle in motion as shown in the figure. So here we have a graph, okay, A, B, C, D, 4 points are shown, okay, distance time graph for a particle in motion as shown in the figure. The maximum instantaneous velocity of the particle is around the point. So again, here we have to find the maximum instantaneous velocity. For that, what you have to do? We have to draw the tangent each and every point. Now as you can see here, velocity is 0, it's starting from 0, so instantaneous velocity at A is 0. Now if you see at B, instantaneous velocity is this, at C instantaneous velocity is this, and at D instantaneous velocity is something like this. Okay. So now what is the instantaneous velocity? So for small time, if the displacement is more, I already told you instantaneous velocity is delta x by delta t, right? This is instantaneous velocity, vi, right? So if delta t is small but delta x is large, then that will give you a higher instantaneous velocity, right? So if you see all the graphs, okay, then you see that here delta t is very small and comparatively delta x is very, very large. So instantaneous velocity is largest for the point C. Instantaneous velocity is largest for point C. Okay, correct answer is C. Okay, but here they have mixed and matched the options, so be careful, answer correctly. Here this C is correct, not that C. Okay, this is the option C and this is the point C. So point C is correct, not option C. So you have to be careful and answer it again carefully. Okay, so these are the small tricks. The teacher might try to confuse you and they want to test that whether you have learned the concept in depth or not. So that's why they will try this kind of tricks, right? Now next question, when a body thrown vertically upward, it will take t time to reach the highest point, then the time taken it to return the ground. So if you throw a body, it goes up and it reaches the top after some time t. So how much time it will take to reach? So this is upward journey, this is downward journey. Now this is very, very beautiful thing. You will learn little bit more about it in work energy power chapter, that energy remains conserved. So that's why what happens is the time taken by it to reach from ground to top is exactly equals to the time taken by it from top to the ground. So time will be same, no matter if you throw it fast, slow, does not matter. Okay, time taken by it will always be same. So it will be t as always t. So if time taken by it to reach the top is t, then the same time is taken to reach the ground as well. And this is the concept also we used in the projectile motion, if you remember, right? Projectile motion also, the vertical motion, where we have calculated that if we throw an object by some u velocity at an angle theta, we always start with the horizontal vertical component and say that whatever time is taken to reach the top is exactly equal to time taken by it to reach the ground, right? And then we multiply it by 2, so that's how we find the total time of flight, if you remember the derivation. We might do it or may not do it, but anyway, if you have remembered it, that is very, very good. Let's move on to the next question. The area under the velocity time graph represents. So velocity time graph. Now it is not position time, this is velocity along. So whenever we say time graph, t is always along the x-axis. T is always along the x-axis. Anything else is always along the y-axis. So velocity time graph, area under the velocity time graph represents. So what is the? So suppose there is a velocity time graph like this. So what is this area represents? So what is the meaning of area? Area means length into breadth, dimensionally. It may not be exactly the, you cannot calculate the area like that simply, but anyway, so area is basically velocity into time, right? Here velocity into time. So what is Vt? Vt is basically nothing but the displacement. So area under the velocity time graph gives you the displacement. So it is basically displacement. Okay, because it's velocity time graph, it gives you displacement. Okay, if it is a speed time graph, it will be total distance travelled. That is the basic difference. Now next, it's a statement based question. Now the statement based questions are getting popular nowadays, and you can expect at least one statement based question, maybe not now, but in your final exam definitely you will get one statement based question. So be ready. Some colleges do prefer to give you some good questions, and in that case they will give you a statement based question. So there will be two statements in the question, okay, and you have to check whether individually they are correct. That is point number one. Secondly, you have to check if the second statement is an explanation of the first statement. These are the two things that you have to check, right? So first check is if both statements are correct or not individually. Second check is if the second statement is the correct explanation of the first statement or not. So first statement, an object may fall with a constant velocity. Object may fall with a constant velocity. Yes, if it reaches a terminal velocity, there is a term called terminal velocity. When it reaches the terminal velocity, then it will fall with a constant velocity. Okay, that means acceleration is 0. Why does it happen? Because of the air resistance. Okay, normally when we calculate, we do not consider the air resistance, but in practicality there is air resistance, and to increase the air resistance, for example, paratroopers, those who dive from the sky, okay, they use the parachute to increase the terminal so that they can have a terminal velocity at some point and decrease the terminal velocity, and slowly they can land on the ground safely. Okay. Now statement 2, this happens when acceleration of the object is equal to acceleration due to gravity. So this happens when acceleration of the object is equal to acceleration due to gravity. So this is not true. This statement is not true. This happens when the resistance force, air resistance force is equal to the weight of the body, weight of the object. So when the weight of the object is equals to the resistive force, air resistance, then only it attains the terminal velocity. This is not correct. So statement A is correct, statement 1 is correct, but statement 2 is false. So option C is correct. Okay. So after you identify the cause and the reason, and the cause and the reason, okay, or effect and the reason, okay, then you have to choose the correct statement. Okay. So in this case this is a correct statement, but this is not a correct statement. So after that you have to choose what is the correct option. If both statements are false, then D would have been correct option. If they both are correct but not correct explanation, then option B. If correct explanation, then option A. Okay, this is how the question is framed. Now let's move on to the fill in the blanks for this chapter. The shortest distance between initial and final position of a body in motion is called. So what is the shortest distance between initial and final position of a body in motion? Shortest distance is called displacement, and total distance is called total distance, obviously. So this is called displacement, right? Speed is a dash quantity. So I have not even looked into the option, because that is the only definition. This is the definition. There will be no other option than that. So displacement is done. So I will mark it. Next is speed is a dash quantity. Let's see, velocity, uniform acceleration, scalar, downward. So speed is a scalar quantity. So obvious, speed is a scalar quantity. A body has equal changes in velocity in equal intervals of time. The body is said to be in. So what is the, if a body is moving, the velocity changes equally. So velocity is changing, it is not constant. Okay, it changes equally in equal interval of time, then what is it? It is called uniform acceleration. This is the definition of uniform acceleration. So you can check that in the option uniform acceleration is given. So correct answer is uniform acceleration. The slope of position time graph of a body in uniform motion gives. So the slope of position time graph of a body in uniform motion gives velocity downwards. Obviously downwards does not make any sense. So when you are in doubt, check the options, and if you say that uniform motion gives downwards, grammatically, sentence wise, English wise, it does not make any sense. So only correct option will be velocity. The slope of the position time graph gives you velocity. In fact, it basically gives you the instantaneous velocity. That would be more accurate. A body moving under Earth's gravitational field, so velocity is done. A body moving under Earth's gravitational field, the direction of acceleration is always, so direction of acceleration is always downwards direction, right? So it will be always in the downward direction. Okay, so downwards is the correct answer for this question, right? Now let's move on to the 2 marker question. Write any 2 differences between instantaneous speed and instantaneous velocity. Very common and most asked question, one of the most asked question. So let's see the answer. Instantaneous speed is magnitude of how fast an object is moving at a particular moment without regard to direction. So it does not depend on direction, but it gives you the how fast the object is moving. Instantaneous velocity is the speed of an object at a particular moment along with direction of motion. So basically instantaneous velocity is same as instantaneous speed, but you have to add the direction. So even if instantaneous speed is constant, suppose speed is constant, so instantaneous speed will remain same for all the instances, but if the direction is changing, then instantaneous speed velocity will change each and every point, even though the magnitude remains constant. Obviously instantaneous speed is a scalar quantity and instantaneous velocity is a vector quantity. Okay, so these are the very 2 basic difference, and this is one of the most commonly asked questions. So be prepared for such questions. Draw position time graph for a body moving in positive direction with negative acceleration. So acceleration is negative, that means as the object is moving, its velocity is decreasing, but you are not asked to draw velocity time graph, you are asked to draw position time graph. So you have to, either you can memorize it or you can understand that as the velocity decreasing, position also decreasing. So this is the position time graph for negative acceleration. In your book they have given some weird graph like this. Okay, don't draw this. This is a much better version of that same graph. Okay, this is just a weird graph without proper understanding. Here you can clearly see that the object is, it will be a curved line. First of all, it will not be a straight line. Okay, if it is a uniform acceleration, if it is an uniform acceleration, it will be like this, velocity increasing. Okay, if it is uniform acceleration, then it will be uniform positive acceleration. So this is positive and this is negative. Okay, so in a positive A, this is negative A. A means acceleration, obviously, right? So you have to remember this: positive acceleration, negative acceleration, position time graph. Velocity time graph is different. Velocity time graph will be a straight line for positive or negative acceleration. For example, if you want to draw a negative acceleration for velocity time graph, okay, it will be like this, straight line but decreasing. Okay, clear? Now next question, draw a position time graph for a body moving with a constant speed. Okay, constant speed, its position increases over time. So this is the position time graph for constant speed. Now again, this is a position time graph. It will be a straight line and it will pass through origin. Okay, constant speed, position is increasing over from time, right? It can start from other point as well, but this is the most common graph. But if you draw the velocity time graph or speed time graph for constant speed, okay, it will be this. Okay, speed is constant. But for position time graph, students often confuse between position time graph and velocity time graph, right? That's why position time graphs are sometimes difficult, velocity time graph are relatively easier to draw. So that's why I have included position time graph, two variations of it, and if you have any other questions, any other doubts, please mention that in the comment section of this video. Now, a body is moving with the initial velocity 5 meter per second and uniform acceleration 1 meter per second square. Determine its velocity after 20 seconds. Easy question. So, initial velocity u is 5 meter per second and acceleration is given by 1 meter per second square, and they asked you to find the velocity, not displacement, because it's a 2-mark question. So, what is the formula? V equals to u plus at, the simplest formula. Okay, simplest formula of equation of motion. U is 5 plus acceleration is 1, time after 20 seconds. So, you have to multiply 20 and you get 25 meter per second. Okay, so 25 meter per second is the final velocity. So, velocity after 20 seconds is 25 meter per second. As simple as that. Questions will not be too much difficult. It will be easy, not very easy, but it will be easy. Now, again derive the expression V is equal to V naught plus AT using velocity time graph. Again V naught, it might come as u plus at or v naught plus at. Okay, in your textbook v naught symbol is used, but most of us generally use u, right. So, either v is equal to u plus at or v is equal to v naught plus at. First of all, you have to draw this diagram. This is the most common diagram and you have to use it for most of the derivations from this chapter. Okay, so first of all, you have to draw this, and from this graph you have to mention that the velocity at point B is v, velocity at point A is v naught, velocity at point B is v, the time taken to reach over here is t. Okay. So, now we have to apply the concept of acceleration. What is the concept of acceleration? Okay. Acceleration is from if you are drawing velocity time graph, okay, then the slope of velocity time graph gives you the acceleration. The slope of the slope, do not use the definition of acceleration here, okay, you have to use the graph, right. So, we know that acceleration is the slope of velocity time graph, VT graph. This is very, very important. They did not ask you to do it from the definition of acceleration. They have asked you to do it from the velocity time graph. So, that is why you have to mention this. This is the definition of acceleration from graph. Okay. So, slope of VT graph gives you the acceleration. So, what is slope? Again, if you see this graph, this triangle is highlighted. Slope is basically the tangent of this angle. Okay. Tangent of this angle theta, or there is one more definition I told you, delta y by delta x. So, delta y by delta x. So, what is slope over here? So, that is, what is the slope over here? This is the triangle, therefore, A equals to, what is the slope? Slope is delta y by delta x. So, what is delta y over here? Delta y is v minus v naught. Okay. So, delta y is v minus v naught by, what is the time, is the, this is the same delta t itself is t. So, that is t. Okay, you can write one more line over here before that, A equals to delta y by delta x. Okay. This is the slope, definition of slope basically. Okay. So, v is equal to v naught, v minus v naught by t, or you can multiply this as at equals to v minus v naught, or v equals to v naught plus at. Very simple derivation. You get 2 marks, 1 mark for this writing this line, 1 mark for this calculation, and 1 mark for this diagram. Okay. If you do not draw the diagram, you will not get any marks for this, because they have asked you to derive it from the graph. So, if you are not drawing a graph, if the question asks you to draw or prove it from the graph, and if you do not draw the graph, you will get 0 marks. Okay, now teacher might be sympathetic to you and may give you 1 or 2 marks, but if I am checking the answer and if this is the first exam that you are taking, so I will give you 0 marks without the diagram. Be very, very careful. Mention 3 applications of velocity time graph. So what are all the applications of velocity time graph? First of all, you can calculate the acceleration. Velocity time graph, the slope of the velocity time graph gives you the acceleration. Okay, there is some explanation given over here, but these highlighting points, if you write it, you will get full marks. Okay, but I have given the explanation because I have not given any theoretical background, so that's why I have given a little bit of a theoretical explanation as well. The slope of velocity time graph gives the acceleration of the body. A steeper slope indicates greater acceleration, while the horizontal line means 0 acceleration. So if it is like this, it is 0 acceleration. Steeper the graph, more acceleration. Point B, determining the displacement. The area under the velocity time graph between 2 time intervals represents the displacement of the body during the time. Okay, so area under velocity time graph gives you the displacement. Slope gives you the acceleration. So from the same graph you are getting 2 information, acceleration and displacement. Okay, secondly, third point is little difficult, which is analyzing the motion changes. So that means if the object is if it is accelerating or decelerating, speed increasing or decreasing. Okay, velocity time graphs help in visually identifying the changes in motion, such as when an object speeds up, slows down or moves at constant velocity. For example, if I give you one graph like this, okay, so here from here to here, this is a velocity, this is time. From here to here velocity increases, okay, v increases, here it is decreases, and here it is constant. Okay, so if the graph is given to you, you can identify where the object is accelerating, where the object is decelerating, or where the object is moving with a constant velocity. Okay, so this is the way to analyze the graph, right? This is also a part of application of velocity time graph. Now a numerical, now 3 marker numerical is very common from this chapter. Even 2 marker numerical can also come, but 3 marker numerical are generally possible from this chapter, right? And there will be a 5 marker numerical, not maybe from this chapter, may not be from this chapter, but again it is possible. A car moving along a straight road with a speed of 126 km per hour is brought to a stop within a distance of 200 meter. What is the retardation of the car? So retardation of the car means negative acceleration. Okay, so what is the initial speed? Initial speed was 126 km per hour. Now here I am going to teach you a cool trick. So whenever the velocity is given in kilometer per hour, don't keep it in kilometer per hour, because the second unit is given in meters. So you have to convert this into meter per second. So how can you convert this into meter per second? So the first thing that you have to do, you have to 126 into 5 by 18. Remember this factor. So whenever you are converting kilometer per hour to meter per second, you have to multiply by 5 by 18, and opposite is 18 by 5. Opposite happens very rare. Mostly you have to convert kilometer per hour to meter per second, and 5 by 18 is the factor. You can convert kilometer, you can convert hour, but if you remember this factor, it saves a lot of time. Okay, so 9 2 is 18. Okay, 2 6 is 12. 3 2 is 6. So 7 9 is 63. 7 5 is 35 meter per second. So initial speed was 35 meter per second. Now this is the initial speed of the car. Now the car is applying brakes. Car is applying brakes. That means, and it is coming to a stop after 200 meter. So when the car stops, what will be its velocity? When the car stops, its velocity will be 0. So final velocity is 0. Okay, now there are two ways to do it. From the beginning you can assume this is retardation, or you can calculate a negative acceleration. Both are fine. I am going to use the basic formula V equals to V square equals to U square plus AS. Okay, I am going to use this formula, V square is equal to U square plus 2AS. I am using plus sign over here. I will get a negative acceleration and then I will call it as retardation. Anyway, both are fine. So now let's put the value. 0 equals to 35 whole square plus 2 into acceleration we are trying to find, or retardation we are trying to find, times distance. S is not time. In all the velocity time graph, S represents the displacement, that is 200 over here. Okay, now put the value over here. So we get A equals to 35 square, there is a negative sign, divided by 400. Okay, so I just did one step jump. So if you are not aware, so 35 square equals to minus 400 A. Okay, I have taken this on the other side, so one of them is minus. Okay, this is how we calculate. Okay, now you can simplify this. 35 into 35 divided by 400. Okay, 5 7s are 35, so it will be 5 8s are 40, 5 7s are 40, 35, 5 1s are 5, 5 6 are 30, so it will be minus 49 by 16, which will be approximately 3. Okay, now you are allowed to use simple calculator in the exam, so you can calculate it. It will be 48 is 3, 16 is 48, so it will be very close to 43. Okay, you can calculate the exact value, but that is also fine. Okay, so this is how you calculate the numerical questions. Fix on the first, you have to declare the initial values and then apply into the formula and calculate the negative sign. Negative sign indicates retardation. Okay, this is a very important line that you have to mention. Now again, this is a 5 marker derivation. This is also very important, not only for your unit test, it is also very important for midterm, as well as it is important for your final exam. Okay, final P1 exam. This is a very common question. Okay, S is equal to ut plus half at square. This derivation you have to do from this graph. Okay, there is a half. Okay, ut plus half at square. Okay, now how to do that? So this is the graph given. Again, from the graph you have to do it. First of all, slope. What is slope? We already did it once. Slope is V minus V naught by time t. Okay, so this is the first line that we have to write. Second is what? Second is what is displacement from this graph. So displacement of a velocity time graph is basically, displacement is the area under the curve, area under the graph or area under the curve. Now you have taken a simple graph over here. So this area, the total area gives you the displacement. Okay, x. So what is the total area? Now you can see that here we have a rectangle AODC and a triangle ABC. Okay, so we can write this as rectangle AODC plus triangle ABC, right? So what is the area of the rectangle AODC? So area of the rectangle AODC is basically length into breadth. Length into breadth. Length is V naught and breadth is time t. So that is V naught t. Okay, V naught t is the area of this. And what is the area of the triangle? Area of the triangle is basically half base into height. So what is base? Base is time. Base is time and height is V minus V naught. V minus V naught. But if you see in this expression, there is no V present. So we have to eliminate it. Now what is the easiest way to eliminate this V? The easiest way to eliminate this V, this is our equation 1. Okay, this is one you have to write it first. So V naught t plus half, whatever I am doing is the shortcut method, shortest method, not shortcut but shortest method. What I have done, I have made this t to be a t square. Why? Because if I multiply and divide, so what I have done, I have multiplied 1t in the numerator and 1t in the denominator. Okay, so that's why, so if you cancel this t, you will get the t. But this is not, we have not done it to cancel. Why we have done it? Because this has a meaningful quantity. From equation 1 we can say this is equals to acceleration. So from here we can write this is equals to V naught t plus half t square into a, or x equals to V naught t plus half a t square. Okay, so this is the derivation that we are trying to do and we have achieved it. Very simple, easy derivation. Okay, only few steps are involved. If you do it this step wise, okay, try to explain the diagram once using few words, that will be great. Otherwise this is the derivation, I mean if you do it, you will get 5 marks. Okay, don't miss out on this point, this is very very important. Okay, and from the graph, area under the graph gives you the displacement. So from there we can write this. Clear? Any doubt, please mention in the comment below. Derive the expression v square is equal to V naught square plus 2ax using VT graph. Again same VT graph we are going to use, and now we are going to derive the expression v square is equal to V naught square plus 2x. Now out of the two derivation, one derivation is very very highly probable that it will come in your unit test. Okay, and one of them will definitely come in your midterm exam as well. So be ready for one such derivation. So let's see. Again slope gives us acceleration equals to v minus v naught by t. Now don't stop over here, from here, because if you see the equation here, time is not involved, time is not involved. So from here we will calculate time, t equals to v minus v naught by t. Okay, this is a, from slope, definition of slope we can write this, and from there we can calculate the time. It will be a. Okay, so just cross multiplication, so a and t exchange their places, time equals to v minus v naught by a. This is the main thing that we have to be calculating, right? Now again the same thing, x displacement x equals to rectangle AODC plus triangle ABCD, right? The method is same. Okay, method is same, plus triangle ABC. Okay, only thing the calculation and the result that we will get is slightly different. Okay, now what is AOCD? V naught t. AOCD is V naught t. So this is V naught, this is t. Okay, this height is V naught, this width is t. Okay, so V naught t is the AOCD area. What is the area of ABC? half base is time. Okay, if this distance is time t, then this will also be time t, right? Time t into height. What is height? Height is v minus v naught. V minus v naught. Okay, now here the calculation method is slightly different. Okay, first of all we have to take half t common. Time we have to take common. Okay, time we have to take common from both this, and we have also taken the half as common as well. That will simplify things a lot. So if I take half t common, there was no half over here, so it will become 2 v naught from the first term. Okay, so if you multiply it, half cancels, 2 cancels, and v naught t, right? Plus half t you have taken common, so what is left? V minus v naught, right? This is left. So what is this equals to? This equals to half t. Now let's simplify. 2 v naught minus v naught, so it becomes v plus v naught. Okay, v naught plus v or v plus v naught. Now we have to put this value. We have to put this value, time t's value, in this equation. So if we put this value over here, we get v minus v naught by a into v plus v naught. Okay, now do the cross multiplication. This 2a will come to this side and it will become 2ax equals to v minus v naught into v plus v naught. That means v square minus v naught square, a plus b into a minus b, or from here we can write v square equals to v naught square plus 2ax. Right? What we have done? We have taken this v naught square on the other side and then we have written it in slightly reverse order. That's it. Small manipulation. Right? So this minus v square come to this side, it becomes plus. So v naught square plus 2ax, and just change the side. Clear? Again simple derivation. Only one trick to remember. Here you have to take half t common, simplify the inside, and then put the value of t from this calculation. Okay, put the value of t from this calculation, and if you do that, you will get full marks. Right? Now, a numerical question from this chapter. A body projected vertically upwards with a velocity of 15 meter per second. Now, this is, it seems like it's a projected, but it's not a projectile motion. Vertical projected means it is projected like this. Okay, horizontal projection means like this. So let's read the question once more. Object is vertically projected with a velocity of 15 meter per second. Okay, from the top of a tower. So it is not only projected from ground, it is projected from top of a tower. So what is here? We have a tower over here. Okay, we have a tower over here, and it is projected vertically with a velocity of 15 meter per second. Okay, it says that it reaches ground in 5 seconds. So it reaches ground. It is not reaching the top of the tower. It is reaching the ground. Okay, it's very, very important. It is reaching the ground after 5 seconds. So 5 second time is taken for the object to reach the ground. So suppose you are standing on the top of a tower, you had a rubber ball, you throw it out up and suddenly it goes down. So you measure the time, you found it at 5 seconds. Okay, don't try to do it at home, very, very risky. So find the height of the tower. So you have to find the height of the tower from this information. So what is important over here? You know the initial velocity, and if the time taken by it to reach the highest point is t seconds, if the time taken by the ball to reach from here to the topmost position is t second, then we know that it will take another t second to reach up to this level. It will take another t second to reach up to this level, and because it was initially thrown up with the velocity 15 meter per second, when it reaches at this point, it will have a downward velocity of 15 meter per second. So, these are the shortcut that you have to understand. Okay. So, t second it will take to reach the top, it will take another t second to reach the level of the tower, and remaining time it will fall to the ground. So, what is the time taken by it to reach the ground from here onwards? So, total time was 5 seconds. So, time taken by it to reach only from the top of the tower to the ground is basically 5 minus 2t. Okay. So, 5 minus 2t is the time taken by the object to reach from the top of the tower to the ground. So, first we will try to find the time t. How to do that? So, easy. When you throw anything up, okay, after some time its speed becomes 0. Okay. So, that 0 speed, so v equals to, our equation is v equals to u minus gt. I am using minus gt over here directly, okay, because when you throw it up, it acts on negative gravitational acceleration, that is why minus gt. Now, v is 15, v is 0. At the top is v is 0, so here v is 0. So, v is 0, u was 15 minus gt. So, what is g? G is given in this question is 10, time t we are trying to find. So, t will be 1.5 second. Okay, so, t is 1.5 second. So, from here we can say that what is the time 2t, total time. So, to go up and come back to the same height, to go up and come back to the same height, it will be 2t. So, 2t is 1.5 into 2, that is 3 seconds. So, 3 seconds is taken by the ball or object to reach from the top of the tower to go up and come back to the same height as the tower. So, how much time is taken by the object to reach from the top of the tower to the ground? It is 5 minus 3, that is 2 seconds. So, 2 second time is taken by the object to reach from top of the tower till ground. Now, what is his initial velocity? Initial velocity is 15. Now, we will use s equals to ut plus half at square, right. So, what is s? Trying to find that value. S equals to, what is u? As I said, once you throw it something up with the velocity, it comes back with the same velocity, right. So, 15 time taken by it to is 2 seconds plus half into acceleration is 10 into 2 square. So, let us simplify, 30 plus half into 10 into 4, that is 2. So, it will be 30 plus 20, that is 50 meter. So, height of the tower is 50 meter. So, this is a very common type of problem that you might expect, the values might change, but this type of question is very common in from this chapter. Okay. Not super simple, but if you understand the concept, what is happening, this is very simple. It will be very simple question, that time taken by to go to the top and come back to the same height, time will be same. So, whatever time is taken to the top and to the same height, time is same. So, total time will be 2t, and if you minus that from the time given, you will get the time from the tower to the ground, and whatever speed you have thrown in, the same speed it will come back. Okay. So, these are the 2 points to remember to solve such question. Now, this is the last question from this chapter. A body let fall from the top of a tower covers 45 meter in the last second of its fall. Find the height of the tower. Another important question. Okay. This kind of question is also common. Now, here question is slightly different. Here we have a tower, and once you have allowed to fall the object, obviously initial speed was 0. Okay, you dropped one object. Let fall means it is just dropped. Okay, so initially its speed is 0, and last 1 second, it covered a distance 45 meter. Okay, now you have to find the height of the tower. Okay, so very interesting. Suppose total time of fall is t plus 1 second. Okay, total time of fall is t plus 1 second. So how much time it taken from here till this point? So time taken to reach from here to here must be t, because this is the last 1 second. This is the 1 second, right? So total time is t plus 1, right? So the time taken by it from here to here must be t. So what is the distance travelled? Suppose this distance is s1, this distance is s2. Okay, so what is s1? S1 is half g t square. Okay, what is s2? S2 is half g t plus 1 square, ut plus half at square. Okay, now in this case u is 0, that's why I am not including the ut term. U itself is 0, so u is 0, right? So ut plus half at square instead of a, the gravitational acceleration, because it is falling downward, right? So it will be half gt square. Now it says that last second the distance travelled is 45 meter. That means s2 minus s1 must be 45 meters. This is given. Okay, so s2 minus s1, the last second distance is 45 meter. Now let's put the values. Half g, okay, half g will be common. Half g will be common. This is s2, t plus 1 whole square minus t square equals to 45. Okay, now let's put the values and simplify this. So first is, let's break this. T square plus 2t plus 1 minus t square equals to 45 into 2 divided by g, that is 45 into 2 by 10. So it will be 5 and then 9. So it will be 9. Now on the left hand side, t square cancels, you get 2t plus 1 equals to 9, or 2t equals to 9 minus 1 equals to 8, or t equals to 4 seconds. So t equals to 4 seconds. So time is calculated. Now we have to find the height. Now if you see this in this diagram, what is height? So s2 is the height. So if you see that this is the height, so s2 itself is the height. So we have to put the value of time in this equation and calculate the height. So g is 10 and t is 4 plus 1, that is 5 square. 5 square is 25. So 5 cancels. So 5 into 25, that is 125. So 125 meter is the height of the tower. Okay, so this is the answer. Height of the tower is 125 meter. Right? Now let's move on to the next chapter. Motion in a plane. So let's look into the first question from this chapter. Which of the following is not a vector quantity? So there are, again it's not a vector quantity, that means 3 of them are vector, only 1 is not a vector. And from the option, let's see, impulse is a vector quantity, displacement is a vector quantity, momentum is also a vector quantity, work is not a vector quantity. Those who have completed the chapter work, they know that work is basically scalar multiplication of two vectors, so it is a scalar quantity. Now let us move on to the next part. If a vector is multiplied by a positive scalar, so if a vector is multiplied by a positive scalar, the resulting quantity, so you are multiplying a vector quantity with a scalar quantity, so the resultant will be a vector quantity, but its magnitude will change. For example, let us see, I am giving you a basic example. 5 is a scalar quantity, and if you multiply with say 3 cap, 3 cap is a vector quantity. So what is the new quantity? New quantity is 15 cap. So it is a vector quantity, but magnitude increases. A scalar, obviously it's not a scalar quantity. A vector having same direction as initial vector, yes, so the direction part is same, so this is the correct answer. A vector having different direction, different is not possible. A scalar, again scalar is not possible. So read all the options and then identify which of the option is correct. If they say that vector having same direction but different magnitude, yes, that is correct. Magnitude, as you can see, initially magnitude was 3, now final magnitude is 15. So magnitude do change, but the direction remains the same. The resultant of two vectors acting at a point is minimum if they are in the same direction, 0, perpendicular to each other 90 degrees, making an angle of 120 degree with each other, opposite to each other. So if two vectors are acting at some point say A, okay, then the magnitude or the resultant will be minimum when they are acting in the opposite direction, so that the angle between them is 180 degrees. Okay, so it is not 90 degree, not 120 degree, not 0 degree obviously, so it will be 180 degrees, and magnitude will be maximum, resultant will be maximum if they are acting in the same direction. So this is for minimum condition, this is for minimum, and for maximum there has to be acting in the same direction, so the angle will be 0 degree. So angle 0 degree for maximum and 180 degree for minimum. So even though we are discussing minimum over here in the exam, the question came when the magnitude will be maximum, you say that sir, you have only taught us the minimum one, not the maximum one, right? So don't have any doubt in your mind, it will be maximum at 0 degree, minimum at 180 degree, and in between values at any other angles. Statement 1, the vectors addition is commutative. Statement 2, two vectors may be added graphically using triangle law of vector addition. So what is the meaning of commutative? Commutative means if A plus B is equals to B plus A, right? This is called commutative property. So now if you are doing the same with the vector quantities, this is also valid, right? So if you are adding them in vector method also, it is valid, right? So vectors are commutative in nature. It does not matter which vector you are adding first, which vector you are adding second. So it is independent of that. That's why vectors are commutative in nature, and vectors can be added using triangle law of vector addition, or even parallelogram law of vector addition. But is it the correct explanation? So I told you before also that whenever you are checking statement based question, generally you have to check both statements are correct or not. So both statements are correct. Here both statements are correct, but second point you have to check whether the second statement is the correct explanation of the first one. So this has nothing to do with the statement 2, right? So triangle law of vector addition is a method to add two vectors. There are other methods, for example parallelogram law, that is also a method. That way also you can add two vectors. So that's why this is a correct statement, but this is not an explanation of that. Both statements are correct, but statement 2 is not correct explanation for the statement 1. So option B is correct. We already know this kind of question, the options are all same for all statement based questions. So you have to identify whether the statement 2 is the correct explanation or not. So based on that you have to answer the question. For maximum range of a projectile, the angle of projection should be. So this is a very common question. So if you want maximum range of a projectile, okay, so the range is maximum for angle of projection for same velocity. If the angle of projection is equals to 45 degrees, then we get the maximum range. So answer A, option A is correct. So for 45 degree angle of projection, you get maximum range. For maximum height of projectile, the angle of projection should be. Now this is a very interesting question, and this is actually, the previous question was very easy, and just to test you that whether you can answer this question or not. Okay, if this question comes directly, I can guarantee that 90% of you who does not understand the concept or does not have those who have memorized the 45 degree angle, they will blindly answer 45 degree. But this is not 45 degree. So height means this is height. Okay, if you throw a projectile, this is called height. So height will be maximum when? For what angle of projection? Height will be maximum if you throw it directly vertically upward. Okay, if you throw it just vertically upward, this is also a projection, this is also a projectile motion, the upward, direct upward motion, right? So if you throw it at an angle of 90 degree projection, height will be maximum. So height will be maximum for 90 degree projection, not 45 degree. Okay, so I give you this, and if this question comes in your midterm exam or maybe in unit 1 exam, then you will later come and thank me, sir, this question came in our exam and I was able to answer it, right? So understand that height is different than that of range. Range is maximum for 45 degrees, but height is maximum when it is just thrown vertically upward, that is angle of projection is 90 degrees, right? Now let's move on to the fill in the blanks. Again, fill in the blanks, the trick is simple. Read the statement completely and find the suitable option. A vector with zero magnitude is called dash vector. So a vector with zero magnitude, we know that is called a null vector. Null vector. So let's see whether null is there or not. Yes, null is there. So null vector. The splitting of a vector into two or more components are called dash of vector. So what is the thing? If you forget, just check resolution. Resolution, first option itself makes a sense. So resolution will be the answer for this fill in the blank. So if you have any doubt, read the options as well. Okay, and even if you still have doubt, leave that question for now, come back later on and try to think and answer. Okay, the resultant of two vectors is maximum if they are acting in. So I just gave you the answer if they are acting in the same direction. If they are acting in the same direction, resultant is maximum. Resultant is minimum if they are acting in the opposite direction or 180 degrees. Same direction is the answer for this question when resultant is maximum. Dash velocity remains constant throughout the motion of a projectile. So if you remember, if a projectile motion can be divided into two components, one along this theta. So this is a cos theta component, this is sin theta component. Now sin theta component varies because it is moving under the motion, influence of gravity, right? So sin theta varies because it is moving under the influence of gravity. This is perpendicular to the gravity. So the horizontal component does not change over time. So horizontal component remains constant throughout the motion of the projectile. So correct answer will be horizontal. The L shifted over here. Okay, so horizontal is the correct answer for this question. Next is, in uniform circular motion, the body moves in a circle with constant dash. So in uniform circular motion, the body moves. So our horizontal one is done. So in uniform circular motion, the body moves in a circle with constant unit, constant speed. So unit does not make any sense. So it moves with a constant speed, right? Unit does not make any sense. So definitely speed is the answer for the last question. So if whenever you are in doubt, check the options and then find the correct answer for that particular fill in the blanks. Fill in the blanks is easy. Only thing, you don't just try to guess it, see if it makes any sense or not. The sentence should be complete and it should be a meaningful one once you complete the sentence. That is the trick for the fill in the blanks. Two vectors of same units have magnitude 9 and 5 units. Two vectors of same units have magnitudes 9 and 5 units. What are the maximum and minimum magnitude of the resultant that can be obtained with the two vectors? It is a 2-marker question. So, I already told you how to calculate the maximum and minimum. So, the maximum resultant R max will be obtained when they are acting in the same direction. So, when they are acting in the same direction, the resultant will be maximum. One is 9, another one is 5. So, same direction means what? They will be added. They will be added. 9 plus 5, that is 14 units. Very important to add this units. Okay, and what will be the minimum resultant value? Minimum resultant value is obtained when they are acting in the opposite direction. This is 9, this is 5. If they act in the opposite direction, the resultant will be minimum, and that is 9 minus 5, that is 4 units. Right? So, this will be 4 units. Clear? Now, next question. Write the expression for resultant of two concurrent vectors A and B and explain the terms. So, two concurrent vectors A and B, that means one vector say A, another vector say B. We have to find their resultant, either parallelogram method or triangular method, does not matter. Method is not important. You have to write the expression for R. So, expression for R magnitude is given by R equals to square root of, and the angle between the vector is theta. The diagram is necessary over here. Okay. So, A square plus B square plus 2AB cos theta, right? This is the magnitude. And what is the angle? See, this makes an angle alpha. If this and this makes an angle alpha with B, makes an angle alpha with B, then tan alpha equals to A sin theta divided by A plus B cos theta. Okay, so this is how you can calculate the resultant angle as well, right? Oh, sorry, there is one small mistake. It will be B plus A cos theta. Okay, A sin theta divided by B plus A cos theta. So, it will be always A sin theta A cos theta and B will be added in the denominator. So, with respect to which you are measuring the angle, that will come as alone, and the other side will come as sin by cos. Sin by cos is tan, which this is also tan, but here it is alpha and this is theta. Now, you have to explain. Let us consider two vectors A and B making an angle theta, then the resultant and angle. Okay, angle with B. Here alpha is the angle made by R vector with B vector. Very, very important. This angle alpha, if you take this angle as alpha, the expression will change. Okay. So, here we are taking the angle with B, that is why it is A sin theta. So, with respect to which you are measuring B, right. So, A sin theta divided by A cos theta plus B. Okay. Clear? Now, what is meant by range of a projectile? Give the expression for the same. what is the angle of projection for which the range of a projectile is maximum. This is a 3-mark question. Each part contains 1 mark. The range of a projectile is the horizontal distance it covers from the point of projection to the point where it lands on the same horizontal level, right. Now, you can draw the diagram is not necessary over here, okay. R is given by u square sin 2 theta by g, right. The range of maximum for theta equals to 45 degrees. We have seen that in our MCQs as well. So, range will be maximum when theta equals to 45 degrees. Explain the triangle method of vector addition. Explain the triangle method of vector addition. So, first you have to draw this diagram very carefully, okay. So, this is a vector, this is another vector. So, this is A vector, this is V vector, and this gives you the R vector. This is very important. First you draw A vector, then you draw B vector. Let me use a different color. So that you don't get confused for resultant. This is A vector, this is B vector, okay, and the resultant is given by this, okay. So, now let us see the statement. The diagram is must. Diagram in this case obviously is must. The triangle method of vector addition is a graphical way to add two vectors by placing them head to tail in sequence. So, this is head to tail method, okay. This is called head to tail method, right. Draw the first vector with its tail at the starting point. So, this is the starting point, okay, and tail means the end point, tail means the end point. So, this is how you draw it. This is tail, this is head. The arrow, wherever you keep the arrow, is basically the head, okay. Draw the first vector with the tail at the starting point. Draw the second vector from the head or tip, from the tip or the head of the first vector. So, now first you have to draw the first vector. Once this vector is drawn, now you have to draw the second vector from the tip of the second vector, first vector, sorry. So, draw the second vector from the head of the first vector. The resultant vector is the side of the triangle that connects the tail of the first vector to the head of the first vector. There is a little bit technically correct and little smaller version is available, but I choose to give you the simplest explanation that you can remember. So, draw the first vector, then draw the second vector where the first vector ends, and then join the end point of the first vector to the head of the second vector. That way you will get the resultant vector in magnitude as well as in direction, magnitude as well as in direction. Derive the expression for time taken to reach the maximum height by a projectile. So, here you have to first obviously draw the diagram. For all projectile based question, you have to draw the diagram, and you can draw this. This angle is theta. So, this is say u, okay. I prefer u, some books prefer v naught, okay. V naught is extra naught for me, extra 0 for me, so I do not want to use that. You can use simple v or simple u, whatever you are comfortable with, right. So, this is u, this component is u cos theta. Now, if you are not aware, if you are the first time if you are doing, you have to remember that the adjacent component, this is called adjacent, because this is just stick to the angle theta, it is just next to the angle theta, that is why it is called adjacent component. So, adjacent component will always be cos, and the perpendicular component which is not in contact is called the perpendicular component, it will always be sin. No matter whatever diagram, whatever configuration you are drawing, maybe it is a projectile motion, maybe just a vector resolution, maybe it is a friction, maybe it is a normal force. So, always remember this, it will help you a lot. So, this will be u sin theta. This is the perpendicular component, it will be u sin theta, and this is the horizontal component, this is the u cos theta. Now height is this. So you have to find the time taken to the maximum height. You are not trying to find the maximum height, you are trying to find the time taken to reach the maximum height. So suppose the time taken to reach the maximum height is given by small t, only maximum height. Okay, so what is the component over here? Upward component u sin theta, and this component is responsible for it to take to the maximum height, right? It is responsible for taking it to the maximum height h, even though we will not use the term h over here. Now we have to find the time. How to do that? So when you throw something up, okay, you have observed that this is very common. You have those who are boys, they have thrown balls. Okay, girls may have thrown balls. Maybe you are a cricketer or you have used badmintons as well. So you have thrown the badminton cock upwards. You will see that after some time it stops and then it comes back, right? So when momentarily at the top of the motion, the ball or the cock or anything that you have thrown, maybe a towel, it stops for some time, then it comes back, right? So at the top of the motion, at the top position of the motion, we can say that the vertical speed, the vertical velocity, final velocity will be 0 at highest point. At highest point, the velocity will be 0, right? So from there we can write that. Now again we know that from equation of motion, v is equal to u plus at, right? V is equal to u plus at. Now what is v over here? V is 0. Okay, for vertical motion, we are only considering the vertical motion, not the horizontal motion. For vertical motion, v final velocity is 0, u is this u sin theta, and the object is moving upward, but gravitational acceleration acting downward, right? So there will be a negative. Instead of a, we will write g, and t is t, okay, or t is equal to u sin theta by g. This is the time taken to reach the top of the or highest point or maximum height by the projectile. This is the very, very important and easy derivation, okay, and 3 mark you will get only for doing this. Also you have to draw the diagram, okay, draw the diagram, show the components, that is compulsory, okay, and you have to mention that you are using only the vertical motion, not the horizontal motion. So this is the maximum, this is the time taken by the projectile to reach the maximum height. So if you throw the projectile, it will take t time to reach over here. So at this point it will reach the maximum height. A stone of mass 2 kg is tied with a string of length 1.5 meter, is rotating in a circle with the constant speed of 10 meter per second. Calculate the centripetal acceleration. So centripetal acceleration is given by a is equal to v square by r. Simple formula, centripetal acceleration is a equals to v square by r. So what is centripetal acceleration? That will be, what is v? V is 10, so 10 square, and the distance also is given in meters, so 1.5. So it will be 100 by 1.5. So it will be 0.320, right? 5, you can cancel it by 5, so it will be 200 by 3, so that will be 66.6 meter per second square. Unit is very, very important. Unit is very, very important. It will be 66.67 actually, 66.67 meter per second square. Unit is very, very important, and as simple as that. Write down the formula, put the values, and solve it. Okay, and you can write the given values. Given v is 10 meter per second, r is 1.5 meters, and what is A, that is our target, right. So, just declare the variables and put the values and calculate it. Show that the trajectory of a projectile is a parabola. This is the most common question asked in the unit test and midterm test and your final PU1 exam as well. This is one of the most common question, along with the question that we studied in the previous chapter, v square is equal to u square plus 2as, or s is equal to ut plus half at square. Those are also very common, and this is also very common question, comes in almost every year in the PU1 board exam. I will not say that as a board exam, that is the PU1 final exam. Up to final exam, if you learn this one derivation, it will be like a work like a charm. Okay, you will face this question. Some colleges may prefer some other derivations, for example height and range. I am not doing height and range in this lecture. Height and range I find it little easier and also most commonly done in across the colleges. This is the derivation that students often ignore, but this is the derivation which comes which is being asked by the teachers again and again and again and again. So, first of all you have to understand what to do. The diagram is, as usual, is compulsory. So, first you have to draw a diagram of a projectile motion. Okay. So, this is the initial speed, say u. Okay. This is the angle theta. This is the horizontal component u cos theta. This is the vertical component u sin theta. Now, what you have to do? You have to consider a point P. You have to consider a point, random point P. Okay, and this is a, what is this, by the way? This is the y axis and this is a x axis, right? So, this actually represents x axis, this represents y axis, right? Now, if you take any, if there is a coordinate system over here, okay, and if the point P is over here, then what is the thing we can write about this point P? We can say this is a random point and we can assign it a coordinate x comma y. Okay, now that same thing can have a path, that same thing can fall on the path of a projectile as well, right? This same point P can fall on the path of a projectile because it's a random point, right? And here we are deliberately taking this point P on the path of the projectile itself. So, here also we will mark it as x and y. Okay, and we will say that the time taken by the projectile to reach from point of projection, that is origin, to point P is given by t. So, t is the time taken by the projectile to reach from O to P. Okay, so everything, if you write it briefly is very good, but otherwise you have to draw the diagram and mention everything in the diagram itself. The diagram will be your weapon to explain everything. So, teacher will see this diagram and he will know, okay, you have understood the concept, you know everything and you are doing it properly. Okay. So, this is the time taken t to reach the point P. This is the horizontal component, this is the vertical component. Now, so now if the time taken by t to reach it over here, then also we can say this is the x component, right? This distance is x, right? If you, the same diagram, if this is P x comma y, then this will be x and this will be y, or this will be y, right? This is x, right? This is the coordinate system. You have learned it in class 10th perhaps, or even 9th, right? And even you will continue to learn that in your sorry, I have erased the diagram, sorry, let me redraw it quickly. now, so this will be the x component, right? This will be the x component, or this will be the x direction, and this will be the y direction, right? Now, the time taken by it to reach from point O to P is t second. The velocity is u cos theta in this direction. So, from there we can say that the displacement along x direction, which is x, is given by u cos theta into t. This is the displacement along x direction, and displacement along x direction is basically the x coordinate itself, right? Because this is the displacement, and displacement itself is v is equal to s is equal to ut. S equals to ut plus half at square. This is the formula, right? Now, here along the horizontal direction the acceleration is 0. So, along the horizontal direction acceleration is 0, along the vertical direction acceleration is negative of g. So, along the vertical direction the acceleration is negative of g. So, x coordinate we have calculated. From here what we will find? We will find the time t. So, t equals to x by u cos theta. Now, remember that this time is a random time. This is not the time taken by it to reach the highest point or total time of flight. This is a random time. Okay, this is a random time. Secondly, what is the y coordinate? Similarly, we can write y coordinate is ut plus half at square. Now, in this case, u will be u cos u sin theta ut minus half gt square. Okay, y minus, because gravitational acceleration is acting in downward direction. Now, this is called a parametric equation. These two equations are called parametric equation. Here time t is the parameter, because it is random. Based on the time t, x and y will change. Based on the value of time t, x and y value will change. That is why it is called a parametric equation. Okay, or y equals to, but this parameter we have to remove. That is our duty. To remove the parameter, we will use the time that we have calculated in the first expression, and we will put that value in the second expression. So, it will be u sin theta into time t is given by x by u cos theta. So, u cancels over here, minus half g into x by u cos theta whole square. Okay. So, sin theta by cos theta is tan theta. So, tan theta into x minus half g x square by u square cos square theta. Okay. Now, this equation can be written as y equals to ax plus b x square, where a equals to tan theta obviously, and b equals to minus half g minus half g by u square cos square theta. Okay, so this is the constant. So now this is, what is this? This is a general equation or common equation of a parabola. Any equation which is represented using this is called parabola. So you may have learned about parabola in your mathematics, but that equation was slightly different. It was y is equal to 4ax square, x square is equal to 4ay, or y square is equal to 4ax. Okay, but that is a very specific equation, not the general equation. This is the general equation of a parabola. This is the general equation of parabola. From here we can say that the trajectory is a parabola. That is what we are trying to do. Now, there is also one more important part that comes with this question, say that what is a projectile motion or define projectile motion. I know many of you know the definition. Projectile motion is the motion of a particle only under the influence of gravity. So, only under the influence of gravity the path of a projectile is a parabola. If there is an air resistance, then this is not a perfect parabola. Okay, it will deviate from the perfect parabola path, but here we have not considered any air resistance or any other resistive forces. That is why you are getting this as a perfect parabola equation. Okay. So, this will be valid only if you ignore air resistance. As soon as you start adding air resistance, it will no longer be a perfect parabola. Okay. Now, next question, this is a 5-mark numerical question from this chapter. The resultant of two forces acting at an angle of 120 degree is at a right angle to the smaller force. The greater force is 8 Newton. Find the smaller force and resultant. Very interesting question. So, two forces, suppose one force is A and another force is B, the angle between them is 120 degree. So, 120 degree means this is must be acting like this is B, the angle is 120 degree, right. Now, it says that the resultant makes an angle right angle to the smaller force. So, B is larger than A. If B is larger than A, then this resultant is basically making a angle 90 degree with the smaller force. So, this is 90 degrees. So, basically if you draw a parallelogram, you will get to see that this is the resultant. This is how we find the resultant, right, and this makes an angle 90 degree with the smaller force side A, right, and the greater force is 8 Newton. So, this is basically 8 Newton. The value of magnitude of this is 8 Newton. What is the magnitude of vector A and what is the magnitude of resultant? That is what we are trying to find. So, now if you remember our diagram, okay, when we are trying to find the resultant of any two vectors, this was our resultant, right, and this angle was alpha, then tan alpha was this vector A sin theta by A sin theta plus B, where the bottom vector was B. Okay. Now, here the same logic, if we apply the same logic, okay, this angle is alpha, right. So, from here we can say that angle tan 90, this alpha value is given over here, So, tan 90 equals to this side B sin 120 degrees divided by B cos 120 degree plus vector A is equals to tan 90 degrees, right. Now, what is the value of tan 90? Tan 90 is basically infinity. That means infinity is equal to B sin 120 degrees by B cos 120 degrees plus A. Now, you might say that, sir, what is this? Infinity is not solvable, but we know that a number can be infinity if the denominator is 0. Okay, so, for example, 1 by 0 is infinity, right. Any number x by 0 is infinity, provided x is not equals to 0. Okay, so, this is only possible if the denominator becomes 0, right. So, a number can be infinity only if the denominator is 0. So, therefore, B cos 120 degree plus A must be equals to 0, right. So, A must be equals to minus B cos 120 degree. Now, what is the value of cos 120 degree? That is the main problem of this. So, minus B value is given 8. So, 8 into cos, or let me write it like this, cos 90 degrees plus 30 degrees. Now, if you see this angle 120 degree, it falls in the second quadrant, all sine, tan, cos, right. So, this value of cos will be negative, and sine 90 plus theta means cos 90 plus theta means minus cos theta. So, that will be minus sine theta. So, it will be 8 minus sine 30 degrees. So, this minus comes because cos is in the second quadrant, that is why the value should be negative, that is why minus is coming over here. Minus minus cancelled. So, 8 into sine 30 degree means what? Half. So, value of A is 4 Newton. So, value of A is 4 Newton. So, the smaller vector is 4 Newton. So, smaller vector we have calculated is 4 Newton. I hope it is clear. So, here only starting point is the angle, the resultant angle and the total angle is given. So, that is how our starting point. Tan 90 is infinity. Now, infinity is only possible when the denominator is 0. So, that is our only hope to solve this question. So, from there we have solved this question, and that is why even though the problem looks difficult, it is not so difficult. Only logic that you need to know that this is only possible when this is 0. Now, what is the value of the resultant? Value of the resultant is a square plus b square plus 2ab cos 120 degrees. Okay. So, a square means 4 square, that is 16, b square means 8 square, that is 64, plus 2 into 8 into 4 into cos 120 degree we have already calculated. Cos 120 degree is basically negative half. So, it will be minus half. So, 2 cancels and we get this as 70/80 minus 32, right. So, this minus will come over here, plus minus minus 4 8s are 32. So, it will be square root of 48, square root of 48, right. So, this will be approximately 6.99, or you can write this as 4 root 3. 4 root 3. Either you keep it like this, or you can almost consider this number to be 49. 49 square root is 7. So, answer will be 6.9. Okay, if you can calculate it using a calculator, or you can leave the answer as it is. Okay, that is also correct. 48 means 3 16s are 48. So, 16 square root is 4. So, 4 into root 3. Okay. So, this is the resultant for this question. Now, next question, another numerical question. A football player kicks a ball at an angle 30 degree to the horizontal with the initial speed of 20 meter per second. Calculate the maximum height and horizontal range reached by the ball. So, diagram is not necessary, but if you can draw it, it will be very, very good. So, this is the horizontal range, this is the maximum height, this is the angle of projection. Angle of projection is given 30 degrees and this speed is given 20 meter per second. Okay. Now, you have to find the first part is maximum height. Part A is maximum height. So, what is the maximum height? Maximum height is given by u square sine square theta by 2g. Okay, u square sine square theta by 2g. So, u square means 20 square, sine square theta means sine square 30 degrees divided by 2 into 10. Okay, now put the values. 20 into 20 by 20 into Sin square 30 means what? Sin 30 is half, sin square 30 will be 1 by 4. Okay. Sin 30 is half, sin square 30 will be 1 by 4, 20 cancels, 4 5s are 20, so maximum height will be 5 meter. Maximum height will be 5 meter. Now let us continue with the part B. What is the horizontal range? Horizontal range is given by u square sin 2 theta by only g, right. Now you have to remember these expressions. So sin 60 degree, okay, 2 theta means 2 into 30 degree, that is 60 degree, okay, g is 10, so it will be 20 into 20 by 10 into root 3 by 2. Okay, so 10 cancels, we have 2 cancels, and you get 20 root 3 meter. So 20 root 3 meter is the horizontal range and 5 meter is the maximum height. Okay. Now let us move on to the last chapter of our discussion, laws of motion. No force MCQ questions first as usual. No force is required to keep an object moving in circular motion. An object moving in straight line with constant velocity, an object moving with constant acceleration, both A and B. Now let us see, this is little tricky. So obviously one of them is correct. An object moving with constant acceleration require force, because force equals to ma. Force equals to ma. So if it is moving with an acceleration, force must be acting on it. So no force is not correct. No force means you do not need to apply any force. Object moving in a circular motion. So object moving in a circular motion, so if it is moving in a circular motion, then it is always getting experienced by a force called centripetal force. Centripetal force is required to keep the object moving in a circular motion. So that means this is also not correct. Okay. An object moving in a straight line with constant velocities, velocity constant means acceleration is 0. So acceleration 0 means force required in this case will be 0. So no force is required to keep an object moving in a straight line in a constant velocity. This is the first law of motion. The question is basically from first law of motion, but options given here are from different parts of the chapter. So this is basically the answer. Now next question, what is the term for an object's tendency to resist the changes the state of motion? So whenever you try to apply force on an object, it resists the motion. For example, I am trying to tell you, please go and study now. You have to study, you have to check all the answers, all the questions that I am discussing. You will see that, sir, I will do later on, before exam I will open your video and I will go through it. So this is an inertia, this is called inertia. So everything has an inertia. Inertia is the tendency to resist the change. Inertia is the tendency to resist the change. When an object A exerts a force on object B, what force does object B exerts on object A? So you have two objects A and B. Now object A exerts a force, say F, on this, and object B will exert a force minus F on this, right? That is the third law of motion. If you apply a force F on this object, it will apply a force minus F on you. So equal and opposite force. So equal and opposite force. So equal force in opposite direction. The most easiest question of all the MCQs. Next, rocket works on the principle of conservation of. So rocket works on the principle of conservation of energy, momentum, mass, all of this. So rocket is a device which works on the principle of all of this, not only momentum. Don't fall for the trap. It works on the principle of energy. Energy changes each and every moment, because when it is rising, okay, its potential energy changes, its kinetic energy changes, so energy is conserved. The mass it goes out of the rocket, that also changes its motion. So that is why rocket motion is one of the most complicated motion, and momentum also obviously it is changing. So all of this is the answer for this question. Okay, not only momentum but mass, energy. If it is simple, only momentum is given, other options are given, then momentum is okay, but otherwise energy, momentum, mass, everything is conserved during the motion of a rocket. And that is why we sometimes say this is a rocket science, because rocket science is one of the most difficult science that human had developed in the early stages. Okay, it was not now, it was developed long back, it was not experimentally done until recently, few hundred years back, still almost 70-80 years back, not 100 years, 70-80 years back, humans started to launch satellites into the orbit. Okay, so that is why it is called rocket science, because it is one of the most complicated science. Next, a cyclist bends while taking a turn in order to. So if you are someone who is driving a cycle and if you want to take a bend, then your body will automatically bend like this, okay, towards the curve. Why it bends? Because it provides the required centripetal force. So whenever you are taking a bend, if you try to take a bend flat way, okay, then what happens is that it is very difficult to bend like that, not because of friction, not because of reduced speed, not because of only reduced speed, okay, it only because to provide the required centripetal force. So whenever you are taking a circular, part circular motion or full circular motion, does not matter, okay, whenever you are taking a bend, it always important to provide the centripetal force, and that is why the component of your weight adjusts itself and provides the required centripetal force. A block of wood is placed on a surface. A force is applied parallel to the surface to move the block. The frictional force developed acts. So here we have a horizontal surface, the block is placed and you apply some force to make it move. What is the direction of friction? Friction will act in the opposite direction, okay, along the direction of applied force, opposite to the direction of applied force, normal to the surface upward, normal to the surface downward. Friction always acts in the direction opposite to that of the applied force. So it will always oppose the motion and it will always act in the opposite direction. Now let us move on to the fill in the blanks. Dash is a measure of inertia of a body. So we already discussed inertia is the tendency to resist the change in motion, and which quantity is measured the inertia? The mass is basically the measure of inertia. Mass is the measure of inertia. So option is mass. When no external force is applied on a system, its total momentum is. So when no external force is applied, the momentum is constant, it is conserved, okay. So momentum is constant. A force acting for a short duration, force acting for a short duration, it is called impulse. It is called impulse. At equilibrium, net force on a body is, at equilibrium net force on a body is 0. Equilibrium means no force is acting, all the forces are cancelling each other, so net force will be 0. The SI unit of spring constant is, so this is little tricky, Newton per meter or Newton meter. Now those who have studied the next chapter, work, energy, power, Newton meter is the energy of work, Newton per meter is the spring constant. So Newton per meter is the unit of spring constant, Newton per meter, basically that is how we calculate it, right. Kx is the force equal to kx. So that means Newton per meter, if you multiply with the length, you will get the Newton back. Mention any two advantages of friction, very important question. So first, friction is a necessary evil, that is another point they might ask you that is little complicated answer, where you have to mention advantages as well as disadvantages, but here they have directly asked you what is the advantages of friction. So, friction, even though it basically have mostly negative things, for example, it does not allow you to move in a high speed, but also it has certain advantages. What is that? First point is it helps in movement. So, friction allows us to walk, run and drive vehicles without slipping. So, because I am able to walk in this surface of the earth, that is because of the friction. If there was no friction, I would have continuously slipping and I will not be able to walk. Same thing happens in an icy road or rainy road. Okay, if the water is there, friction reduces drastically and there is a chance of slipping. Okay, without it we would just slide around. Okay. Now, second point is it enables gripping and holding objects. Friction between our hands and the objects helps us to hold things securely, like a pen or a cup. So, if you are writing in your exam, okay, the main reason that you are able to write exam is the friction. Two reasons. First of all, the friction helps you to hold the pen. For example, I am holding this pen in my hand because of the friction. It is not falling because of the friction. Also, when you are writing, the ink sticks to the paper, that is also because of friction. If there was no friction, for example, if I try to write on an oily paper, you will not be able to write anything because the friction is very less there. Okay, so the ink will spread, you will not get a clear write up on a oily paper, right. So, the exam that you are writing is basically the fault of friction. So, maybe it is not so much advantageous for you. If there was no friction, there would have been no exam for you as well, right. Just kidding. Next, what is an impulsive force? Give an example. Impulsive force, very important. An impulsive force is the force that acts on a body for a very short duration, but is extremely large in magnitude. Despite acting for just a brief moment, it produces a significant change in the body's momentum. Okay? So, even if works for a very small amount of time, it gives a very large change in the momentum. Okay. So, there are few examples. Hammering of a nail. When hammer strikes a nail, the large force is applied for a brief instant, driving the nail into the wood or into the wall. So, this is one example. Any one example is sufficient. I gave you two examples for obviously for different students. Some students may be able to remember it. For some students this is very interesting. Batting in cricket. Okay, when a batsman hits a ball, the bat exerts a huge force in a very short time frame, rapidly changing the ball speed and direction. For example, when Virat Kohli hits a ball, it goes to the out of the boundary. Now, you might think that he is just doing it like this, but he actually exerts a lot of force in the ball, but the time of contact is very less, and it is very important to contact the ball at the right moment, so that the transfer of momentum happens and the ball can travel a very long distance. Okay. Similar thing can happen if God forbid it does not happen to you, if two cars collide. Okay, collision between cars. Okay, so if you have seen accidents, the accidents happen on road. When two cars collide, the huge amount of momentum is transferred, and because of that, there are some safety precautions are taken in modern day cars, right. So, that is also an impulsive force, when that contact period is very less, but momentum transfer is huge. Now, next, what is banking of roads? Why banking is necessary for a curved road? Banking means if you travel on a curved road, you will see that one of the edges of the road is basically curved like this. So, if you are driving on a road, curved road, you will see that the end of the road is curved like this. This is called banking. This angle is called banking angle. Banking of road is the process of raising outer edge of the curved road. So, this is the outer edge, this is the inner edge. Okay. Outer edge of a curved road above the inner edge, creating an incline at a specific angle. So, this angle is very specific based on the road condition and the amount that you want. okay, creating an incline at a specific angle. This inclined surface is designed so that when a vehicle negotiate a curve, the normal reaction from the road surface has a component that acts towards the center of the circle, providing the necessary centripetal force for circular motion. So, now if you I know some of you may be watching that, some of you may not have watched it. So, if you are someone who is an FA1 fan, Formula 1 driving fan or MotoGP fan, you will see that the road on which those drivers drive, they are very curvy, and on the curves there is the side in which they take the turn is actually slightly narrower and the other side is slightly upper. Why it is so? Because when they take the turn at the high speed, okay, there is a chance of skidding. To prevent that, then naturally it will provide a centripetal force, and that will help the car to negotiate that curve at high speed. There is a limit of that speed, obviously. If the car moves higher than that speed, there is a high chance of collision or skidding and hitting the boundaries, right. So, and in case of MotoGP, you will see that the driver, when driving through the curve, he himself bends his body, he touches his knee onto the floor, and then he takes the turn. Why so? Because to adjust the required centripetal force, and it helps them to take the turn at a high speed without applying brakes. That is the major important. If you lose speed, that means you are losing the race as well. So, that is why it is very important to take the turn at a very high speed. You have to adjust the curvature of the road itself. State and explain Newton's second law of motion, define SI unit of force. Okay, so this is only definition. Derivation we will do, derivation is also important for this formula, we will do that. The rate of change of momentum of a body is directly proportional to the applied force and occurs in the direction of the force. Okay. So, rate of change of momentum of a body is directly proportional to the applied force and occurs in the direction of the force. Mathematically, F is equal to ma, F is force applied, m is mass of the object, a is the acceleration produced. Okay. This is the state and explain Newton's second law, and SI unit of force is Newton. SI unit okay, so they have to define the SI unit, that is important. Okay, wait. So, how to define SI unit? Okay. So, if m equals to 1 kg, okay, a equals to 1 meter per second square, then F equals to 1 Newton. So, SI you have to write it like exactly like the way I am saying. So, SI unit of force is defined as SI unit of force is defined as the amount of force required to accelerate an 1 kg object by 1 meter per second square is 1 Newton force. Okay. Okay. So, this is how you have to, first you have to write this and then you have to write this statement. If you write 1 Newton, Newton is the SI unit of force, you will not get any marks. If you simply write Newton is the unit of force, you will not get any marks because they asked you to define. So, the definition is when the mass is 1 kg, acceleration is 1 meter per second square, the required force is 1 Newton. That is how you define the SI unit of force. Okay. the definition 1 Newton is the force required to accelerate a 1 kg mass by 1 meter per second square. This is the simplest definition. This is also you can write. Now, next question, mention any 3 methods of reducing friction. Mention any 3 methods of reducing friction. First method is lubrication, applying lubricants like oil, grease, polishing the surfaces, making surfaces smoother by polishing, that also reduces friction. Using ball bearings, replacing the sliding friction with rolling friction by using ball bearings. So, ball bearings basically convert linear motion into rotational motion, and that way rotational motion is less than that of the linear friction, rotational friction is less than that of the linear friction. That is why ball bearings are also very helpful, and it is used across multiple components. If you have seen any cycles, bikes, cars, everywhere you will see that ball bearings are used. Next, derive an expression for maximum speed of circular motion of a car on a level road. So, maximum speed of a car during a circular motion on a level road. This is a 3-mark question. You are taking a turn. There is no curvature of the road, there is no banking of the road. A car is simply taking a turn on the level road. Now, what are all the forces acting on it? First of all, there is a force, downward force, which is the weight of the car. Okay, there is a centripetal force acting on this. The car is moving with a velocity v. Okay, there is a frictional force. I will not draw it like this. The centripetal force is acting in this direction, right, and there is a velocity which is acting in this direction, and there is a force of friction. Okay, now what is, now if you draw the upward view, okay, so mg is acting in this direction, then natural force, normal force is acting in this direction. The frictional force in this case will act. So, the car when taking a turn, it has a tendency to slip in this side. Okay. We were not considering the backward friction. Backward friction is there, but we will not consider it. That is not helping us. That is only reducing the force, velocity, right. But when the car is taking a turn, okay, there is a tendency that it will move away from the curve. So, there is a frictional force which is acting in this direction. This frictional force is important. Okay. So, this frictional force is acting in the direction of the centripetal force. So, basically this friction force is providing the required centripetal force. So, centripetal force is equals to frictional force for safe turning. In case this frictional force is insufficient, then this car will move away. Okay. And suppose the curvature of the road, curvature of the curve is r, then from there we can write mv square by r is actually equals to f. Now, what is f? F is nothing but coefficient of friction times normal force. Now, normal force must be equals to mg. So, mv square by r must be equals to mu mg. M cancels, or v square equals to mu gr, or v equals to square root of mu gr. Okay, this is the maximum safe speed on a, flat road. Okay. Now, there is a banked road calculation as well. Some college might give that question to you, but that derivation is really tricky, and if you already have practiced that and understood that concept, you should try that or attempt that. Otherwise, I have seen students attempting that, but in the end of, or on the middle, from the middle point of the derivation, they completely forget it and they make it a mess, and they answer it wrong. So, try to avoid that question. That will be a 5-mark question. This question will come as a 3-marker question, but if that question comes as a 5-marker question, avoid that, try to answer any other questions that is there. There will be options for you, don't worry about it. So, try to answer alternative questions, not that question, the friction maximum speed on a banked road. Okay, it came once or twice when the board used to take the paper, PU1 paper, but I will recommend do not try that derivation. Remember the formula for your competitive exam journey in future, but otherwise do not try to derive that. That is a very difficult formula to derive. Okay, only for the students who are very good, and I know most of you are watching this video are not into that category. That's why I recommend that you should not try that derivation. State the law of conservation of momentum. Prove the law of conservation of linear momentum using Newton's laws of motion. So, let us see, the total linear momentum of an isolated system remains constant if no external force acts on it. So, this is the conservation of momentum principle. Now, we have to derive this. How to do that? First of all, you have to consider two objects, object A and object B. Initially, object A is moving in this direction. It has a momentum PA and it has a momentum PB. So, both are moving like this. They are about to collide. Okay, object A is moving in this direction, object B is moving in this direction, and they are about to collide. Okay, during collision, when they are actually colliding, object A is applying a force on this. Okay, F on B due to A, and object B is applying a force on A due to B. Okay, so they are applying a force on each other. Okay, object A is applying BA, object B is applying AB. Okay, after the collision is over, what will happen? Two objects are coming towards slowly each other, and then they collide, and then they will start moving in the opposite direction, right? Now, the final momentum of this, say PB dash, and final momentum of this, say PA dash. Okay. Now, from second law of motion, this diagram is compulsory, otherwise you have to write the description. If you draw this diagram, teacher will know you have understood that concept and you are doing it on your own. Okay, from second law of motion, okay, FAB. So, force AB is acting on object A. So, what is the second law of motion? It is basically the force acting on an object is directly proportional to the rate of change of momentum. In fact, we know that this is exactly equals to change in momentum, rate in change in momentum. How to calculate the rate of change of momentum? That is nothing but final momentum minus initial momentum divided by the time during the collision. This is a small time. Suppose they are in contact for a time delta t seconds. So, that is the force AB. Similarly, force BA will be given by final momentum minus initial momentum by delta t. It is always final minus initial. Okay, in thermodynamics also we will see always final minus initial. Okay, final is important, right? So, now this is from second law. From third law, what is the third law statement? Third law states that whatever force is being acted on A by B and whatever force is acting on B by A, they should be equal and opposite, right? Because it is an action reaction force. This is an action reaction force. So, from third law, FAB must be equals to minus force BA, right? Now, put the values. PA dash minus PA by delta t equals to PB minus PB dash minus Pb by delta t. Obviously delta t is constant, so they will cancel. From here we can write that Pa dash minus Pa equals to minus Pb dash plus Pb, or Pa dash plus Pb dash equals to Pa plus Pb. Now what is this? What is the meaning of this? What is Pa dash plus Pb dash? So Pa dash plus Pb dash is the combined final momentum. What is Pa plus Pb? Pa plus Pb is the combined initial momentum. So we can say that final momentum equals to initial momentum. No external force acts on these objects, they only are acted by internal forces. So when two objects collide, that is an internal force, right? So we can say that the total initial momentum must be equal to total final momentum, that is the conservation of momentum principle. So this is the derivation for conservation of momentum principle, simple and easy, right? Now let us move on. State Newton's second law of motion, hence derive the relation F is equal to ma, where symbols have their usual meaning. Now state Newton's law of motion I have already explained. I will only derive the expression here. Okay, how to start derivation. So Newton's law states that force acting on an object is directly proportional to rate of change of momentum. So force acting on an object is directly proportional to rate of change of momentum. Now you can do it if you are good with calculus, you can use calculus, but I am not using calculus, I am just using simple formula. Okay, so this is directly proportional to rate of change of momentum. Now what is rate of change of momentum? Suppose you applied a force on an object, and because you applied the force, the momentum of the object changed by delta p. So initial momentum was say 10, now you applied the force, final momentum is 15. So what is change? Change is 15 minus 10. Now if the duration is delta t, then 5 by delta t is the rate of change of momentum. This is the definition of rate of change of momentum. Now what is momentum, by the way? So momentum is basically given by a quantity mass into velocity. This is a vector quantity, this is the momentum, mass into velocity, or delta p is equals to delta of mv. Now mass is usually constant. Okay, there are very specific cases where mass is not constant. In that case you cannot use F is equal to ma directly, you have to start from this equation. Okay. Anyway, mass is constant, so we can write delta p is equal to mass into delta v. Okay, mass into delta v. Now let us put that value in this equation, and we get this as F proportional to m delta v by delta t. Okay, again mass is constant, so delta v by delta t. What is delta v by delta t? Delta v by delta t is the rate of change of velocity. So rate of change of velocity. So what is rate of change of velocity? Rate of change of velocity is basically the acceleration. So force equals to mass into acceleration. Now this is still in the proportional stage. We have to remove the proportionality constant, and here we have to write F is equal to kma. K is the constant of proportionality, right? Now here you have to define K. Okay, here you have to define K. If force is defined such that when m is equal to 1, a is equal to 1, then F equals to 1, not force, sorry, this is the unit of force. So, up to this point unit of force was not defined. Okay, so you can take the liberty of choosing particular unit of force such that when m is equal to 1, a is equal to 1, f is also 1, then we can say that if we put those values in the equation, what we will get, right. So, unit of force was not defined up to this point, that is the advantageous part. So, from here we can write that force is 1, K, M is 1, A is 1. So, that will be K is equals to 1. Okay. Therefore, F is equal to M into A. In vector form, F vector equals to M A vector. Okay. Now, remember two things you have to remember. I have seen students, they do up to this point correctly and then they suddenly put K is equal to 1, which is not correct. This portion you have to write. This portion is very essential and you have to write. There are some books where they do the derivation and after that they put K is equal to, let's put K equals to 1. Let us put K is equal to 1. That means there is a liberty that I can choose the value of K. So, what if I choose value of K is 100? Let us put K is equal to 100. Then this can be F is equal to 100 MA, Y MA, right. So, K is not arbitrary value. K cannot be written like let us put K is equal to 1. No. You have to write this very careful. There are some PU colleges which might allow you to write K is equal to, let us put K is equal to 1, but if you are writing this in any other boards or if you are teaching it to some of your juniors later on and if you say them let us put K is equal to 1, that is not correct. You have to understand that. Okay, you have to define K and then only you can write F is equal to MA, right. Clear? Simple derivation, just practice it once or twice, you will be good. A driver of a car moving at 25 meter per second sees a child on the road 70 meter ahead and stops the car 20 meters earlier to the child. If the mass of the car with the driver is 1000 kg, calculate the force exerted by the brakes on the car and the time taken to stop the car. So, here we have a car and there is a child. Okay. So, car sees the child when the distance was 70 meter and after some time the car stops 20 meters before reaching the child, right. So, what is the displacement? The displacement of the car is basically 50 meters. Okay, displacement of the car is 50 meters. Now, so displacement is given by 50 meters, the initial velocity is 25 meter per second and because the car applies a brake, so car comes to a complete stop at this point. So, final speed is 0. V square is equal to U square minus 2a s. We have to calculate the acceleration first. Okay. Not acceleration, in this case retardation. So, V square is equal to U square minus 2as. From here 0 equals to U is 25 square minus 2 into acceleration into 50. 50 is the displacement, 70 has nothing to do, 20 has nothing to do, basically 70 minus 20, that is important, that is 50. So, from here we can say that 100 into A is equal to 625. 25 square is 625, 2 into 50 is 100, this comes to the left hand side. So, from here we can say A equals to 6.25 meter per second square. So, what is the force? force equals to mass into acceleration. Mass is 1000 kg and acceleration is 6.25, that is 6250 Newton. So, this is the force. Also you have to calculate the time taken by the car. To find the time taken by the car, V is equal to U minus AT, okay. V is 0, U is 25 minus A is 6.25 into time t. So, t equals to 25 by 6.25. So, it will be 25 on the 25 and 0.25. So, it will be 4 seconds. You can check it using a calculator. I don't need calculator, okay. You are allowed to use simple calculator. So, in this case, if you see that calculation is slightly difficult, you might use the calculator. Otherwise, if you are smart enough, you will not require a calculator and you can solve it without a calculator. Without solving a calculator is a art that you have to practice right now if you want to get success in future. Now, last question of the day: a body of mass 2 kg is attached upon by two perpendicular forces 4 Newton and 3 Newton. Calculate the magnitude and direction of the acceleration of the body. So, a mass, it is being acted by two forces 4 Newton and 3 Newton. Okay, first you have to calculate the magnitude and the direction of the acceleration of the body. So, first we have to find the resultant force. So, what is resultant force over here? Resultant force is given by square root of 3 square plus 4 square. Now, 2ab cos theta is not required because the forces are perpendicular, that means cos theta is 0. So, 2ab term is 0. So, when vectors are perpendicular or forces are perpendicular, in that case you just need to do the simple Pythagoras theorem. So, it will be 9 plus 16, that is 25, that is 5 Newton. So, 5 Newton is the resultant force. So, what is acceleration? Acceleration is resultant force divided by the mass. Force is obviously ma, father is ma, F equals to ma, right, however you want to remember it. So, force we have calculated is 5 Newton and the mass is given 2 kg. So, the resultant acceleration is 2.5 meter per second square. Now, this is not done yet, you have to find the direction. Now, the resultant force is acting in this direction. So, resultant acceleration will also be in the same direction as the applied force, resultant force. Now, if this angle is say alpha, then we already know what is the angle alpha. Tan alpha equals to this force 3 sin 90 divided by 3 cos 90 plus 4. So, 3 cos sin 90 is 1, cos 90 is 0. So, 3 by 4. So, tan alpha is 3 by 4. Now, 3 by 4 is a very specific value which is equals to 37 degrees, that represents 37 degrees, tan 37 degrees. So, alpha equals to 37 degrees. Okay. So, this is the answer for this question. So, this is a trick question, maybe appearing to be difficult, but it is not difficult. Only thing that you have to remember, because forces are perpendicular, you have to find the resultant force first. Once the resultant force is calculated, to find the direction, use the simple vector direction formula. So, if you can do that, you will be able to answer this question. And if you are watching this video for the first time, or if you have not yet subscribed to our channel, definitely I will request you to subscribe to our channel and share this video with your friends, so that you get all the helps that you need, not only for your unit test, maybe for your midterm and obviously for your final exam as well. We will be bringing up more videos for you very soon. Till then, bye.